On tonight's video, I'm going to go over the worksheet problems that I gave you in class today. So I strongly suggest that you try doing these problems on your own first and working them out all the way to the end to the best of your ability, and then you can go through these solutions with me. So on number 3, there was a very similar question on a previous video about a person walking away from a street light. Here's a street light. Here's the person. 18 feet, 6 feet are constant, so they're marked as 18 and 6. M is for man. The man is walking away from the street light in this direction. And the 5 feet per second is dm dt. We want to find out how fast the shadow is lengthening. I called this H for shadow. We want dh dt. We're given dm dt. This is a similar triangles question. 18 over m plus h equals 6 over h. Cross multiply, and if you simplify it down as far as you can, you get m is equal to 2h. And at that point in time, when you can relate the two variables in an equation, you take the derivative. And after you take the derivative, you plug in the information. dm dt was 5. 2h, 2 dh dt. So you divide both sides by 2 and you get 5/2 feet per second as the rate. The next question. Two people are 50 feet apart, and now this angle theta is changing, so this angle is labeled with a variable. This is changing, and the person is moving in this direction. So x is also changing in a positive rate. So at what rate is the distance between the two? What we want is dx dt. I think we said that in class today. We want dx dt. We're given d theta dt is 0.01 radians per minute. And since this is a right triangle, and we know we're talking about an angle and two sides, we can set this up as a cosine. Cosine of theta is equal to adjacent over hypotenuse, and I just wrote that as 50 times x to the negative 1. I'm going to take the derivative because these two are variables, and the derivative of cosine is negative sine, so negative sine of theta d theta dt, and taking the derivative of 50x to the negative 1, you get negative 50x to the negative 2 dx dt. Now the only thing that we don't know at this point in time is we don't know the value of x. And oftentimes we get to a situation where we don't know one of the variables that we're going to have to plug in. So at that time, we're going to go back to the original equation where the two variables are related to each other. And given that theta is 0.5 radians, we can plug in cosine of 0.5 and set that value equal to 50 over x, and we have to solve that for x. So down here I said we also have to find x when theta is 0.5. So I just plopped that into my calculator, and x turned out to be 56.9746967. I didn't round that at all. So now when you get back to this part of the equation where you took the derivative, you just plug in that value for x. You plug in 0.5 in for theta, and d theta dt turns out to be 0.01. Make sure your calculator's in radians mode, or else you're not going to get any of these numbers right. So just check the mode on your calculator. And in the end, dx dt turns out to be 0.311 feet per minute. Next, we have a trough question. Trough question is very similar to the one I put on a video previously. And when you have a trough question, you have a similar triangles question. This is W, they tell you, and this is H. So W over H is equal to 5 over 2. And so you can set this up with a similar triangles proportion. And because they want to know what is the rate of the height of the water changing, they want to know what is dH dt. What is it? So the volume of this trough, remember the volume is base times height. Well, the base is a triangle, so the base is 1/2 times W times H. And the height of this is 8. So there's your volume. 1/2 times 8 is 4. W gets replaced because we want dH dt, so we only want h's in our formula. So when you simplify this down, you get 10h squared over on the right-hand side. Now that v and h are related to each other with an equation, at that time you take the derivative with respect to time, and you plug in 6 for dv dt because that's given information. H, now the only trick here is they give you the height in centimeters. 120 centimeters, that is actually equal to 1.2 meters. Hopefully you can do that conversion. So 1.2 has to go into for your height instead of 120. And then when you solve this for dH dt, you get 0.25 meters per second. Now the last one is a little bit trickier because we haven't talked about anything having to do with 1 revolution. So in this picture, if you can imagine this boat, this is a pulley being, this rope is being wound up by this pulley. So the rate that this rope is being wound up is 1 revolution every pi seconds. Well, 1 revolution is actually a circumference, right? If you go around 1 revolution, it's 2 pi r. Well, they tell us that the radius is 1 foot. So 2 times pi times 1. The circumference of this is 2 pi feet. So because it's being pulled in at 1 revolution every pi seconds, I called this A, B, and C because it's a right triangle question. B is a constant 10, A changes and C changes. dC dt is the rate at this that the rope is being pulled in. So because it's being shortened, it's negative. Right? If this was lengthening, it would be positive. So the circumference, it's 1 revolution for every pi seconds. Here's the revolution, here's the pi seconds. And when you cross out the pi's, you get -2 feet per second. That's the rate of change of C. They want to know what is dA dt. When 15 feet of rope is out, so we have to substitute 15 in for C and use an a squared plus b squared equals c squared to figure out what a is. Well, a turns out to be this long decimal, 11.1803399, if you use Pythagorean theorem when c equals 15. So once you get these two variables related to each other with the Pythagorean theorem, you take the derivative. I just simplified it down by canceling out the 2's. You get dA dt. Now c is equal to 15. dC dt we figured out way back here was -2, and you divide it by a, which we figured out was that 11 point whatever. And so the rate of change, this a is negative because it's getting smaller, 2.863. I just rounded it to 3 decimal places, and that's in feet per second. So that's about all I'm going to do as far as videos go on related rates. I think I've given you a number of a big variety of examples. So study hard for that quiz tomorrow. It's not going to be all that tricky. There's going to be no trig on it. And we'll see you then. Bye.